Okay, we want to determine the horizontal and vertical asymptotes and any other points of discontinuity for the following rational function. Why do I call this a rational function? Because it's in the form of a what? Fraction with a numerator and denominator. So the first thing you want to do is you want to factor f of x. So I'm going to say that f of x is equal to, how can I factor the numerator? 1, 2, 3 terms, coefficient of 1 in front of the x squared. We know that as a simple trinomial. You look for two numbers that add to give 5 and multiply to give 4. Think about what multiplies to give 4. 1 times 4 or 2 times 2. Which numbers also add to give 5? 1 and 4. Positive 1 and positive 4. Be clear on that. And then I would rewrite this as x plus 1 times x plus 4. Yes? Do the same thing on the bottom. Two numbers that add to give 6 and multiply to give 8. So it's 1 times 8 or 2 times 4. It's 2 times 4. I'll go x plus 2 times x plus 4. Wicked. What can I do from here? How can I simplify this further? I can divide away the x plus 4s. Okay? That factor x plus 4 is in the numerator and the denominator. They would just become 1s. We say cancel. That's great. But all I'm left with now is the following. X plus 1 over x plus 2. I want to find the horizontal and vertical asymptotes. When it comes to the horizontal asymptote, this is what we learned yesterday. I want to find the limit as x approaches infinity of the rational function. Now, you could use the factored form x plus 1 or the original. Like I could go back to this one. If I was using the original, I would divide everything in the numerator and denominator by x squared. If I'm using the factored form, I'm going to divide everything in the numerator and denominator by x to the first, the highest power that is present in the denominator. This is something that we did in chapter 1 of this course. So my next line will read the limit as x approaches infinity. It would be x plus 1. I'm going to leave a little space over x plus 2. And I'm going to divide all of these by x. And this is a mathematically legal move. And this is how I solve infinite limits of rational functions. Simplify that. What's x divided by x? It's a 1. This doesn't simplify. It's just going to be 1 divided by x. And this doesn't simplify. Sorry, this does simplify to a 1. This term doesn't simplify. It remains 2 over x. Before I go any further, I should remind you that, like, initially, I should have tried direct substitution. If x is getting bigger and I add 1, the numerator is just going to get bigger. And getting bigger means it's going to positive infinity. Okay? X plus 2. If x is getting bigger and I add 2, the denominator is blowing up as well. That's called an indeterminate limit. That's why I had to do the following. Okay? If direct substitution led me to 0 or infinity, that's great. But not infinity over infinity. So I'm going to walk that back. Should have tried that first. Cool? Now direct substitution will work. Because what happens if you take a constant 1 or a constant 2 and you divide it by infinity? What happens to that term right there? Like this first term in the numerator remains a 1. But what would this become? Remember the example? We talked about it yesterday. 1 divided by 10 is 0.1. 1 divided by 100 would be 0.01. If I make that denominator 1,000, if it gets bigger, I end up with 0.0001. Okay? it keeps getting smaller, but it's not going to go to like negative 10 or negative 50 or negative infinity. It's actually approaching 0. Same thing with this one. And you end up with 1 plus 0, 1 over 1 plus 0, 1. What's 1 divided by 1? So that means my horizontal asymptote is at y equals 1. Remember, the horizontal asymptotes have the equation y equals, where the vertical asymptotes have the equation x equals. Fair? And if I had changed this to a negative infinity, it would work out to be the same. I could check the limit as x approaches negative infinity of x plus 1 over x plus 2. Direct substitution would lead to a negative infinity over a negative infinity. All right? That's indeterminate. That's no good. If I divide everything by x, that is going to work out to be 1 over 1 as well. It would still work out to the same thing. Your questions will only end up with one horizontal asymptote. Yes, Sloan? Well, you should check the negative just so that, like, this, you should write this because that provides helpful information. Now I know that if I move to the extreme left, so like if I had a grid here, the further left I move and the further right I move, I would know that my curve is bending towards a height of 1. So it's either going to be going like that or like this, or maybe it's above. But that's the situation. That's why it's helpful to write this. Okay? Now, you don't have to graph anything today. You just actually have to figure out where these things are. So where's the horizontal asymptote? Y equals 1. That's what we learned yesterday. How do you find the vertical asymptote? What do you do to get the vertical asymptotes? This is what we did on Friday and on Thursday. I set the denominator equal to 0. Now, I want to use this, the factored form. So my rational function says x plus 1 over x plus 2. What is the denominator in that rational function? X plus 2. So I take the denominator, x plus 2, and I set it equal to 0. Does anyone remember what the zeros of the numerator give me? Like what value would make the numerator 0? What plus 1 equals 0? Negative 1. Good. Do you know what happens when x equals negative 1? That was like from the first lesson we did. That is your x-intercept. Okay? Back to vertical asymptotes. What would x equal? Negative 2. Okay? So I have a horizontal asymptote at y equals 1 and a vertical asymptote at x equals negative 2. You just have to figure out where they are. Cool? You do not have to do this on today's worksheet. I do not have to check to the left of negative 2. And I do not have to check to the right of negative 2. You could, because you are going to have to do this on a test. Okay? But it's not asking for this. So this, what I'm doing right now, isn't necessary for today's worksheet. All right? I will get you to do it on the assignment, so we may as well figure it out. What's a good number to test on the left of negative 2? X equals negative 2.1. And if you fill that in here, what's negative 2.1 plus 1? What would the numerator work out to be? Do you agree it would be a negative 1.1? And this would be negative 2.1 plus 2. That would be a negative 0.1. What's a negative divided by a negative? Positive infinity. That means if I approach negative 2 from the left, my curve would be bending upwards. Yes? What am I going to do on the right? What's a number that is just on the right of negative 2? negative 1.9. Wicked. Plug that in here. Negative 1.9 plus 1, negative 0.9. What's negative 1.9 plus 2? Positive 0.1. And a negative divided by a positive is a negative. And what do I write after the negative? Infinity. Because I can actually make that number smaller by going closer to negative 2, like choosing a number like x equals negative 1.99. That would give me an even smaller number than negative if I choose x equals negative 1.9. And that would mean this, like on the right, as I approach negative 2 from the right, my y values would be getting smaller. And there's what your curve would look like, something like this. What height would it be bending to towards here? 1, and same thing over here. So vertical asymptote at x equals negative 2, horizontal asymptote at y equals 1. Fair enough? That part is just review. Those are the things that we did the last couple days. Now, if I check the solutions to 17K, it says the horizontal asymptote is at y equals 1. You see that? And it says the vertical asymptote is at x equals negative 2. But then it says the following. It says, owing to the fact that x plus 4 appears in both the numerator and the denominator, the function also has a point discontinuity. They might say removable discontinuity at x equals negative 4. So here's how you find the point or removable discontinuity. And remember, a point discontinuity or a removable discontinuity, that creates a hole in the curve. So I look back up here, right to the very beginning where I started to factor things. What factor did I cancel? The x plus 4s. So I take that value or that factor and I set it equal to 0. And I solve for x. So that would mean there is a hole in the curve when x equals negative 4. If I had canceled an x plus 2, there would be a hole in the curve when x equals negative 2. If I had canceled an x minus 2, I would take the x minus 2, set it equal to 0, and I would solve, and there'd be a hole when x equals positive 2, right? The thing is, it has to completely cancel. So I want to show you what I mean by that. Let's say I had f of x equals x plus 1 over x plus 4 squared, and then I have an x plus 2 over x plus 4. Like I can do some canceling here, like this would cancel one of those, and I'd be left with this. That won't create a hole in the curve. There's still an x plus 4 in the numerator. There would be an x-intercept, okay, at x equals negative 1 and x equals negative 4. The zeros of the numerator. Okay, no hole. Vertical asymptote at x equals negative 2. X-intercepts at x equals negative 4 and negative 1. And to find the horizontal asymptote, I would expand this, and I'd see that I'd get an x squared, and I'd divide everything by x, and that would leave an x in the numerator. I'd end up with infinity. There's no horizontal asymptote. This one would actually have a slant asymptote, but that's a lesson for another day. Other situation, if I change this around so that it says x plus 1 times x plus 4, and on the bottom it had an x plus 2 and then an x plus 4 squared, well, this would cancel, but it doesn't completely go away. There's still an x plus 4 in the denominator. That would give me two vertical asymptotes, one at x equals negative 2 and one at x equals negative 4. This one would have a horizontal asymptote at 0, y equals 0. I would multiply this out, divide everything by x squared, and you end up with a horizontal asymptote at y equals 0. So when do you get a hole or a point discontinuity or a removable discontinuity? When the factor completely goes away. Do you see how there's no more x plus 4s in the numerator or no more x plus 4s in the denominator? And if you wanted to figure out where that hole would be, so I know there's a hole when x equals -4, I would take my f of x equation, which says x plus 1 over x plus 2. If I want to know how high to draw that hole, or what height the hole is at, I just fill a -4 in for these x's, and I'd work it out. Anyone know what -4 plus 1 is? Anyone know what -4 plus 2 is? What's a negative divided by a negative? Positive 1.5 or 3/2, whatever you want. And here's what it would mean. Okay? It would mean that where I drew my rough sketch, if I went, so like, if I drew a little grid here, let's try and do this better. Bring our graph out. Where was the horizontal asymptote? You told me it was at y equals what? 1. There's the horizontal asymptote. Where was the vertical asymptote? -2. So there's the vertical asymptote. X equals -2. What did we say was happening as I approached -2 from the left? My y values were getting what? Not smaller. I think they were getting larger, right? What was happening as I approached -2 from the right? They were getting smaller. So that was this value here, way down here. And I know that the further right I move, the closer I come to a height of 1. I'm not going to do anything more than that. And the further left I move, the closer I come to a height of 1. How do I draw that hole? Where was the hole when x was -4, y was 1.5? That means I'm going to go 1, 2, 3, 4 to the left, and I'm going to be up 1.5 blocks. I'll draw a hole. So I actually have to do a little better job with this branch over here. My curve would look something like this. I give it a little sound effect there. Cool? Now, you don't have to draw the curve on today's sheet. All you have to do is factor, solve for the horizontal asymptote, y equals 1, solve for the vertical asymptote. You don't have to do that part on the worksheet. You do have to do this part on the assignment. And then find the hole. Cool? So we'll stop the video right there and you guys can do the assignment.